Everybody loves it. Except there's an issue with, deploying on Ethereum, about gas prices and the scalability. Well, with the rise of L2s in the past, I would say 2 years, it's been evident that, Ethereum there need to be scaling solutions for Ethereum. We all know about the blockchain trilemma. Does anyone here is not familiar with the blockchain trilemma? No? Okay, cool. So, pick 2 out of 3 is basically what the issue is, and Ethereum focuses on the first 2. So, enter ZK rollups. Who's not familiar with ZK rollups at all? Okay. So raise your hand if you're familiar with type 1, 2, 3, 4. If I say type 1, 2, 3, 4. What, so you don't know? What is type 1? No? You don't know? You do or you do not? Okay, cool, no, it's cool. That's the whole point. Rollup solutions like optimistic rollups, became big, I think 1.5 years ago, because basically what it allowed is for off-chain computation and to verify what the transactions were later on. However, who knows how long, it's called fraud proofs. How long does it take for an optimistic rollup to, verify the transactions? Does anyone know here? Pedro? Usually a week. Yeah. So theoretically, they basically say, up to 2 weeks, but practically, Pedro is right. In 1 week, basically, if no one challenges the transactions, we can assume that it's okay. ZK rollups work different. It's a rollup. You aggregate many transactions into a single rollup block, generating an off-chain small cryptographic validity proof. A lot of words basically means, you take on an L2 the batch of transactions, you commit the data on an L1. Simultaneously, what happens is another component will generate a proof and tell Ethereum these transactions are valid. And we'll show it in a picture in a bit. The whole idea is off-chain computation, avoiding costly transactions and no re-execution, gas fees are reduced, and data is compressed. So this is what I meant with the type 1, 2, 3, 4. Vitalik wrote an article because ZK Summer was there. Like a lot of parties started to deploy ZK rollups. Has anyone heard of Polygon ZK EVM? Yes? No. So they are a ZK rollup solution. Has anyone heard of Linea for consensus? Yeah, they are also a rollup solution. ZK Sync Era, another one. But they're not all the same. So even though they use zero knowledge, they're actually a little bit different from each other. And the difference is all in how their virtual machine works. So everyone is familiar with the Ethereum virtual machine, basically the piece, the layer on Ethereum that takes your code, and executes it, very simply put. And the challenge is that you want an L2 that basically for a developer doesn't change the developer experience. So right now you code in Solidity, right? What if I told you, now you have to code in another language, but you get all these major benefits? Most people started learning Solidity and they're not really looking for another language to again adopt, which poses another set of challenges. So along came these 4 types of ZKVMs, and I should actually say 3 because a type 1 is actually out of scope. A type 1 you can classify is that the virtual machine acts and operates exactly like Ethereum. So it's 1-to-1. However, to generate the proof, so on an L2, to post on L1, takes a long time. So again, why do you need to prove? Is so Ethereum knows, because the transactions don't happen on Ethereum. The transactions happen on the L2. So Ethereum needs to know, hey, are these transactions valid or not? And the proof does that. So the discussion is really from type 2 to type 4, where type 4 is ZK Sync Era as an example, where you write your code in Solidity, it recompiles it to the language of their VM. I actually don't know what it actually is, Rust or another language. And this is called like a high language level of compatibility. Why would you do that? Because basically the proofs generated are much faster. Now, as you move up to the types, the generation of the proof takes longer and longer because the Ethereum virtual machine is actually, I would say, relatively slow or inefficient by design, so that the nodes would need low resources to run. So you and you and you, everyone can run a node. So it's by design that they did create it like this. However, to generate the proof, it takes a longer time as you move up in the types. So very simply put, scroll a zkVM layer. Where are we? Type 2. So, and what does that actually mean for the developer, especially like if you're not into all this stuff? It basically means that your developer experience is exactly the same as Ethereum. That's what we're aiming for. So we want to give you all the benefits of a ZK rollup without telling you, you have to go through a compiler, need to learn a new language, or that your proof takes a lot of time. So basically, in simple, that's not simple, but in simple words, we try to make the dev experience as boring as possible, so you can focus on getting the benefits and deploying a ZK EVM. So another word for ZK EVM is a bytecode level ZK EVM. Who does not know what bytecode is in this context? Raise your hand. I'm gonna call you out if you. Okay, cool. It's good. So Solidity, when it's processed by EVM, what it does is translates the code into opcodes. So push, what you call. Now I'm being called out, push, blah, blah, blah. And then that is actually translated into bytecode. So if you go into a transaction, you see a long string of numbers, actually, if you go into the raw output. And that's actually what the EVM processes. And that's what a type 2 aims to do. It takes the code, translates it to opcode, translates to bytecode. Again, the benefits here on is... I have to do a super fast track. So the benefits here are, very simply put, the TLDR is your dev experience remains the same. You can reuse the same wallet. You can use the same dev tools, a high level of interoperability because everything, quote unquote, just integrates is the same. So our goal is to make the dev experience boring, but in a good way. So you get, again, all the benefits, but you don't have to do it in another language. So this is, generally speaking, how that rollup would work. So you have here Ethereum, where you have two contracts, a bridge contract and a rollup contract. The bridge contract is basically used to get your ETH from, let's say, Gurley on a testnet or a mainnet Ethereum to your L2. So it's not a sidechain, it's a pure L2. Then the relayer takes that, and then you might notice that there's no validator here, because on this L2 the architecture is different. The sequencer takes takes all the data, all the transactions, sends them to the coordinator, and sends them back to the relayer. And then on the rollup contract is where we basically, not inside the contract, but we call the transaction, and then the data is posted. I'll show you in a bit, very briefly, what that exactly looks like. But simply put, the relayer calls a transaction or a function on the rollup contract, and inside the metadata, you'll see all the transactions that happen in the sequencer. Why do we do this? Data availability. Tomorrow, Scroll doesn't exist. We rely on the security and decentralization of Ethereum, and that's how we are, quote unquote, secure and safeguarded. The coordinators, after the sequencer goes to relayer, goes to the roller. So these are the prover nodes. And what they do is they start to generate the proof that these transactions are valid. And they pose, and once they generate it, go back via the relayer. Can you see that? Yeah, so via the relayer, get posted on the rollup contract. Inside this contract, it has the ability to verify the proof. So now, in simple terms, Ethereum knows, hey, I got a badge of transactions, 1, 2. I also have the proof that these transactions have been processed correctly, i.e., I didn't maliciously increase your bank account or wallet address account or decreased yours. So in other words, malicious state manipulation. Okay, so where's the validator? Well, that's not there. I'm just going to go through this quickly because I want to spend the last couple of minutes on how to deploy on Scroll. The sequencer takes the role of, as the validator takes the broadcasts transaction, generates the block. That's what the sequencer does. Our prover nodes are decentralized. In simple terms, it's we kinda, because we still run our own network, but the provers, once we go into mainnet, everything will be completely decentralized, and you can run your own prover. And the full flow looks something like this. So the sequencer, a user transacts on L2. The data is committed on the rollup contract. And simultaneously, the coordinator sends it to the roller network, so the prover network, prover generated. However, you see here that the prover is, in terms of blocks, is posted later. It's because it takes time. Remember in the optimistic example, up to a week. The reason why ZK is an alternative for the community, this is just generally speaking, you don't have to wait a week, but at the most, proving times were like 3 hours, and they are decreasing now steadily to some claiming to do it in a couple of minutes. Most do it around 20 minutes or less. So instead of waiting for a week, after 20 minutes, hey, these transactions, they are valid, and Ethereum knows these are valid, and a user can transact, no need to wait for your assets or any rollback or anything like that. So transaction details, if I just go to this link, I can actually see you. So this is the smart contract address, smart contract on Gurley, in this case, the testnet. And this is what it would look like, the metadata, if what the sequencer posts. So I'll just make it, as you can see, it's just data uncompressed. It's just a transaction. It's all there. It's not sexy at all. But this is basically, how the sequencer interacts with L1 and how data availability is safeguarded. Does anyone have any questions so far? Wow, been very clear. All right. So honestly speaking, I was gonna do a walkthrough of the how do you deploy, but it's actually super simple. So instead of doing it, I will actually show the code in Truffle, Hardhat, Remix, and Foundry, and I'll just show it. And then there's only one adjustment that you need to make in Foundry. Does anyone here use Foundry? Raise your hand. You, okay. There's a specific legacy flag that you need to use. It's not just for scrolls because of some updates that happened in Solidity. So I will. Who uses Hardhat? Raise your hand. Hardhat, you. Okay. Who uses Truffle? No one. You. Do you know you can deploy a smart contract without passing your private keys with Truffle? So no .env file. All right, let me show you that. Let me show you that first. I mean, this to me was like wow. So if I just go to, I think it was, yeah. Okay, so here's a simple Truffle project. It's just an Ether wallet that I created. No specific configuration over here. If I go to config. This comes, by the way, with the new Truffle. So if you have the latest Truffle installed, this is all filled in for you. You don't actually need to do anything. If you go to terminal, and I think I have already running. Yeah, I already have running. So if you just type Truffle dashboard and click, and I think I have it already running. What happens is this pops up. So this is their dashboard. By the way, you can plug this into Hardhat. I'm not sure if I'll have time to show you. If you use Hardhat and you don't want to pass your private keys, come find me at the booth. I will show you how to do it. It's 2 lines in the config, so maybe I'll just like sneak in extra time and show you. But this is what the dashboard looks like. So it will prompt you to connect. You connect. Well, I already connected. What you then can do is, was I here? Yeah, you can do Truffle. Well, I actually don't know exactly the. So I'll go over here. And does anyone use Brownie here? No? You? No, you rock. Brownie. I need to know where my Python devs are. So it's basically this command over here. Okay, I'll just try it. Run it, it compiles it. And then it sends it to the dashboard. And as it says here, it says waiting for approval. So over here you can see it sends it transaction. I say confirm, MetaMask pops up, confirm here, and then it deploys. No private keys have been passed. So I think that the cool thing as well is that Truffle plugs into Hardhat, which I can show you now as well. If I so over here I have a Hardhat project. If you got Hardhat config, just like how you add any other network to it, you can add with 2 lines Truffle dashboard, and then if you run the command npx Hardhat deploy, I've got it over here as well. I'll just show it real quick. So here, so you can do the directly on the network, so to say, or you could do over here and say Truffle dashboard. All right, that makes a ton of sense. So it says it deploying contract, and over here you can see this again. This is with Hardhat. So instead of calling the network where you want to deploy, it will just use the dashboard, and it checks which network you're connected to on MetaMask. And so this is done with Hardhat, confirm, and then again you deploy without passing any private keys. I couldn't get this to work with Foundry. Checked with the Foundry, with the Truffle team. It's not compatible yet with Foundry, but if you find a cool hack to make this work with Foundry, definitely let me know. And if you're using Brownie, find me, because adding the network can be a real bitch. So I'll help you. I'll help you with that as well. Any questions so far on using Scroll? It's really just bridging your ETH from Gurley to L2 and then replacing the RPC URL. We've got postcards. Don't have them here. I have them at the booth, where it just shows you everything. You can also jump into our Telegram, and then if you need any ETH, we can send it directly to you if you don't want to bridge. Sometimes it takes a bit of time, but honestly, if you just this is the data. If you just pass the RPC URL, the chain ID, that's really all you need to do. This is what it looks like. And yeah, so for Foundry, by the way, final thing I'll show. So for Foundry, at the very end, so after passing your private key, etc., at the very end, you need to add the -- legacy flag. So if you add the -- legacy flag, you're good. It'll deploy. All right. Well, thank you very much.